than an minus 1. Which one is an right now? 3. Which one is an minus 1? 4. So the first rule says, that is, if an is greater than an minus 1, then you have to interchange. That means instead of 4, 3, if it happens that this number, I assume 37, 86, 34, the last two digit position is an is greater than an minus 1, that is 4 greater than 3. If it happens, then we have to simply interchange that, and that will be the next permutation. That means this particular number, whichever I have given right now, this is basically a permutation of 37, 86, 34. That means I am talking about its previous permutation, that could have been 37, 86, 34. And then from 34 we have changed to 43 following the rule 1, suppose. But this time we are considering this number. So with respect to the rule 2, as Simran has mentioned, that rule 2 corresponding thing, so the rule 2 will apply. Because why rule 2? Because rule 1 is not applicable. What is rule 1? Now an is greater than an minus 1. 3 greater than 4? No. So that's why what is the rule 2 it is talking about. So rule 2 is saying that check the digit and identify a position where your a j plus 1 is greater than aj. What is? Certainly I am switching from nth point to j. That is a j plus 1 is greater than aj. Why? Because right now an and an minus 1, that relation is not there. That's why we will switch the position. So let's apply that rule on this number, and I hope that would be clear. So 3 greater than 4? No. That's why you are switching your positions. So you are coming to 4 and 6. Make the point clear. You check first 3 and 4. 3 greater than 4? No. That's why you check the next previous two digits. That is 4 and 6. 4 greater than 6? No. That's why again you will switch to its previous. That is 6 and 8. 6 greater than 8? No. That's why again you will switch to its previous position. 8 and 7. 8 greater than 7? Yes. So rule 2 is saying stop at that position when your aj plus 1 is greater than aj. So the position is aj and aj plus 1. Which one is the position? Aj means 7 and aj plus 1 means right now 8. I hope that is clear. Aj means 7 and aj plus 1 means 8. So right now your situation is 8 is greater than 7. That is aj plus 1 is greater than aj. So aj's position is 7. Once you have observed that you have reached to that particular position when aj plus 1 is greater than aj, now you have to replace the ajth value with someone. So which one is aj right now? 7. So that 7 it will be replaced. Now that 7 it will be replaced by whom? That 7 it will be replaced by someone who is greater than 7 but least. Again the rule is someone who is greater than aj but that must be least. So greater than 7, how many are there? Greater than 7 towards the right. Again greater than 7, where to check? Greater than 7 element I have to check towards the rightmost position of aj. So rightmost position of aj, there we are having 8, 6, 4, 3 individual digits. So which one is greater than 7? Only one digit right now, that is 8. So just because only one options right now we are having, that is greater than 7, that is 8. So we will do what? We will replace that 7 by 8. That means right now my initials it will become like this, 37. Hey, sorry, that is not 38. Because I will replace that 7 by 8. So it will become 8, that 7 position, at ajth position, 38. So what are the remaining digits there? Remaining digits are something like 7, 6, 4, 3. So it is saying the rule 2 is saying, permutation rule 2, that is arrange the rest of the digit in increasing manner. Arrange the rest of the digit in increasing manner. So 3, 8. What would be the next portions? Simran? Arrange the rest of the digit in increasing manner.
Sir, it will be 3, 4, 6, 7.
No, 3/8 already we have identified. I hope that is clear how we have obtained that 38.
Yes.
Then the rest of the digit. Oh, acha, one more 3 is there. Okay, okay.
Yes, sir.
You said 3,
3, 4, 6, 7.
4, 6, 7. 3, 4, 6, 7. Absolutely. So this would be our final permutation. 3, 8, 3, 4, 6, 7. So this is the next permutation of 37, 86, 43. So this way it works. Is that clear?
Yes, sir. Yes, sir. It's clear. Thank you, sir.
Sir, can you explain the pigeonhole concept you taught us? Actually, I am having doubt there. The whole thing, pigeonhole.
Okay.
I mean, I can't understand now.
Okay. So before going to the pigeonhole principle, regarding this combinatorics, any more doubts are there? That means combination and permutation corresponding. So before moving to that pigeonhole, so I've given one number just because we just learned that rule. So try to figure it out what would be the next permutation. 87, 54, 32.
It is already the highest number.
Exactly.
Not
So
possible.
Absolutely. Absolutely. Good observation. Thank you.
Yes.
So I hope the approach is clear to all of us. So it is already the highest number as he mentioned. That is the correct thing. So we have to observe appropriately. So rule 1, rule 2, definitely we have to check, but depending on the situation. Fine? Okay. Okay. So uh, Najneen, you asked for that pigeonhole principle. So the pigeonhole principle corresponding approach is that uh, think about about a box where says certain pigeons are there. So if we assume arbitrary number, I am considering 5 pigeon boxes are there where pigeons can stay. Fine. So suppose 5 pigeons are already there in your home. So those 5 pigeons, they can stay in one of the pigeonhole singly. I can put them separately. Fine. Now once you have put all these 5 pigeons within those 5 pigeonhole uh, individually, then if it happens that suddenly another pigeon comes, now you have to put that pigeon within that pigeon whole setup corresponding thing somehow. So what will happen? The extra pigeon you will put in one of that pigeon hole whichever already existing there. Now just because you have ensured one thing at this moment of time, that individually one pigeon is present within this individual pigeon hole right now, if I assume, then the extra pigeon definitely you have to put in one of the existing one, that means where certain pigeon is already there. So if it happens that this is the situation, then the outcome is saying that at least one pigeon hole must be there with more than one pigeon. If that is the situation, then definitely that is ensuring one's criteria or condition or situation, that is one of the pigeon hole it will have one pigeon extra. That is one possibility. Another possibility, say check this way.
কমই দিচ্ছিল
Suppose out of those
ময়ূর
5
বাড়তে
pigeon
লেগেছে
hole,
গাদা
you
গাদা
have used only 4. So fifth one is empty, suppose. But right, at the initial stage, how many pigeons you are having? 5 pigeons. Now, if you put those 5 pigeons within those 4 holes, because your intention is to keep empty one of the pigeon hole, what will happen? Those 4 holes individually, if you put, again one pigeon hole will be there where you have to put one extra. There is more than one. And if the last pigeon comes, either you can put that pigeon within the empty hole, or you can put the pigeon within a hole where already some existing pigeon is there, or you can put the pigeon in a hole where actually you have put 2 pigeon already. So that time if I put that, it will become 3, that the particular pigeon hole corresponding count. So anyway, if you go, then that is ensuring one thing, that is at least one of the pigeon hole will have more than one pigeon. Now more than one, it is not that 2 only, it can be 3, it can be 4, but that is quite ensured one. More than one pigeon must be there. So if that is the concept, let's think about a real life situation, and then only you can realize that this is the quite obvious thing, and that we are considering as a counting technique. Say if I consider one information that in a room certain persons are there whose date of month or birth month is uniquely present there. Some persons are there whose birth of months are unique: January, February, March, April, this way. So if I assume this condition at initial stage, that is their birth months are unique, look, something is happening here. That is, this way, if we increase the persons number 1, 2, 3, 4, 5, 6, 7, 8, what is the number, so that I can ensure that 2 persons with the same birth month we can have? Najnin?
Sir, these thing I can't understand why it is happening, because
Okay.
you know when we are putting that pigeon concept, we are putting the pigeons in different boxes, and then extra pigeon comes, and then we are putting this any of the boxes, and how can I distinguish which box this pigeon is choosing, or this to put the pigeon is chosen by me or someone? How can we distinguish that?
Okay, so it is saying that pigeon you can put at any position, at any hole. That extra pigeon which is coming later, that pigeon you can put at any position, any box, any hole. Now if you put that, what is the possible situation? Now say I said that 5 pigeon holes are there, and I'm considering that you are having 5 pigeon already. So what is the possible situations right now at the initial, whenever the extra pigeon is not there? So either singly you can put those pigeons within those holes, and that is expected with respect to pigeon. That is the that can be one of the approach. That is, all these pigeon hole you have occupied using certain pigeon. Another situation is possible, that is, no, you have used one and only pigeon hole where you have put all those 5. So you are having 4 empty. So only one you have used, and the 4 empty is there, empty pigeon holes are there. That is another situation. This way already you are ensuring something. That is, if you follow this approach, that means at least one of the pigeon hole it is having more than one pigeon. That concept or criteria it is fulfilling. Without using that extra pigeon, if the extra pigeon comes, either if you put the extra pigeon within your existing pigeon hole where already 5 present, you can add that, and the count it would be 6 there within that particular hole. So either you can put there in that manner, or the extra pigeon if you put in any of the 4 empty position, whether the condition is matching, what is, at least one of the pigeon hole must have more than one pigeon. Yes, already you have done that situation, already you have created that situation. But in the worst case situation, if I assume that no, I have maintained a rule that is every pigeon you better put in a empty position at the initial moment of time. So that means 5 pigeonhole we are mentioning. So 5 pigeons I can put individually within those empty hole right now. So all pigeon holes are occupied by a individual pigeons right now. Now the situation, if it happens that extra one pigeon comes, then that pigeon it can go anywhere. Either you put it at the first position, but second position, but third position. Whether that is ensuring the condition, that is one of the pigeonhole it will have more than at least one of the pigeonhole it is having more than one pigeon. Yes, that will ensure that thing. That means the extra pigeon definitely I have to put in one of the existing. So this way it is ensuring the situation. This way. So either you can have the this condition by criteria already you have generated. That is one of the pigeonhole already it is occupied by more than one. If you try to follow that one, then the extra pigeon either it is coming or not. In both way it is ensured one. That is one of the pigeonhole is having more than one pigeon. So that is the situations I tried to compare with that date of a birth of month corresponding thing. That is,
Sir, just like if we divide by n the number, I mean n plus 1, which we are considering, two of them will have same remainder.
Absolutely.
Okay, sir. Now I understand.
And that's why I was saying that if I consider those unique birth month, something like January, February this way, and how I can ensure that what would be the total number so that two persons birth month it will be same. So this way you are approaching January, February, March, April, December. That means if you go up to December, you need 12 persons whose birth months are unique. And then whenever the 13th person comes, that extra PG and corresponding thing, then look carefully that definitely that person's birth month, it can be either January or February up to December. Anyone if it is, whatever it is, that is not an issue, but that is ensuring something. That is that person's birth month must be matched one with someone's existing. So that's why if it happens that 13 is the number, the total number of person, 13, then that ensures that two persons birth month is same. This way. So the calculation it is with respect to the total number of pigeon, to the number of pigeon holes with respect to that. Definitely, as you mentioned, that approach we can follow.
Sir, why we are subtracting the remainder at the last of the solution to make this multiple of n or like 0 and 1?
Look, if I say that 12 is the birth month, total maximum unique birth month is 12. So if we go with the multiple of 12, that is 12, 24, 36. This way, what is ensured one? Try to relate with the problem. I hope that will help you. If we go with this way, 12, 24, 36, some information is confirmed one. So if it is 12, what information I can confirmly say? That is there are unique persons whose birth months are unique. There are persons, at least one person is there whose birth month is February, whose birth month is January, something like that. But once I am saying that total persons, suppose it becomes 24. So this way, what we can ensure, we are thinking in that way. So 24, what we can ensure. Then again, another set of birth month we have considered. So that means January to February to this way it is happening. So once it is becoming 24 plus 1, that is 25. That way it is ensuring what? 3 persons birth months are same.
মানুষের পায়ে ব্যথা হতে পারে না, আচ্ছা ঠিক আছে আমি সেটা মানলাম, আমি ডিস্টার্ব করলাম না, আমি সকালে উঠলাম,
সকালে ঘুম হয়নি, সব মানুষকে বলতে হবে যে আমার ঘুম হয়নি, আমার শরীর ইয়ে করছে ও করছে।
Okay.
সকাল রাতে ঠিক করে ঘুমটা হয়নি, সকালবেলা খাবারটা হজম হচ্ছিল,
আচ্ছা, before
রাত করে শোয়ার সময় কিছুই হয়নি, ওই দুপুরবেলা
going to
তখন
the
থেকে
next
অ্যাসিড হয়ে আছে
query,
পরোটা খেয়ে সকাল থেকে। ওর পরোটায় ব্যথা বাড়া, ওর পরোটার ব্যথা থেকে আমি ইয়ে করে
I
বেড়াবো,
want to
লাফিয়ে বেড়াবো।
discuss
একবার
about
আমি ওষুধ বললাম, ওষুধ পর্যন্ত লাগাই না।
property.
তাকে
Actually,
কি করবো
this
আমি?
particular
নিজে যেতে তুমি আবার আটকে আছো।
thing we skipped during the time
আমার
of
হয়নি, আমি কোনো এক্সাম দিতে গেলে আমার
explanation
হয়নি
of
এরকম
binomial thing.
পিছনে ব্যথা,
So
এক জায়গায় একসঙ্গে গ্যাট হয়ে
that's
নিচে
why I
ভেঙে
must
বসে হয়েছে,
mention
কতবার
today,
হয়েছে।
because today
লাগিয়ে
we are
দিচ্ছি
having
অটোমেটিক,
time.
ওটা মাসেলটাকে হিল করে সঙ্গে সঙ্গে, ঠান্ডা জলে কিচ্ছু হয় না, কিচ্ছু হয় না।
So I hope that how
সিঙ্গেল
to
একটা জ্বালা
utilize
পর্যন্ত হয় না আমার
binomial
সাথে।
coefficient in case of counting problem, that approach is clear to us.
পরোটায় ব্যথা, এখানে ব্যথা, ওখানে ব্যথা করে লাফিয়ে বেড়াচ্ছে। তো পরোটায় ব্যথা, আমি পরোটা আগে মালিশ করতে হবে নাকি? আমি নিজেকে তো ওষুধ মালিশ করতে হবে, যখন প্রবলেম হচ্ছে সেখানে ইয়ে করতে হবে।
জুতি লাল করে দেবো এবার, জুতি লাল করে দেবো।
So these are the this is the expansion of the binomial theorem, and as we know that
আমি তো বললাম, আমি তো এবার বেরিয়েছি বাজারে,
every term
আমি বেরিয়েছি
present
বাজারে।
in the expansion of the
আমি
binomial
তো যাবো
theorem,
সঙ্গে,
nc0, nc1, ncn minus 1, these terms, those are known as
ব্যাগটা আমি
binomial
ভরে আনতে
coefficient,
পারবো।
and these coefficient represent something.
কেন
What
তাই
it
নাকি?
represents? Now these coefficient represents,
বাজারটা করতে
that
হবে
is
তো,
how
ওগুলো
many
তোমার সঙ্গে
ways
যেতে হবে, ব্যাস।
I can select. Suppose this nc1 represents how many ways I can select n minus 1 number of x and 1 y. That is a combination of n minus 1 number of x and y, because it's a choose nc1. So n minus 1 number of x and 1 y, in how many ways I can choose, and that is the coefficient nc1 that helps us in counting that combination, how many ways we can combine them. So that's the approach we learned already, but we have idea already. So that is why if I follow that approach, that is how many ways we can arrange x and y. Suppose this one I'm talking about, how many ways we can arrange 12x and 13y, 12x and 13y, a combination of 12x and 13y. Then the answer is that we have to identify the coefficient of that x to the power 12, y to the power 13, and the answer is this way we are observing. So that is one of the another counting approach where we can apply that binomial coefficient and we can identify the total count. That is how many ways we can arrange 12x and 13y. So x, say consider that x is a Cadbury and y is a 5-star. How many ways I can select 12 Cadbury and 13 5-star if it says in that manner. So using that binomial coefficient, we can solve this way, fine. But along with that approach, one more observation is there, which is also important, and that is the observation is saying coefficient of x to the power a r in the expansion of 1 minus x to the power whole to the power minus a. And that is saying this is the coefficient of x to the power r in case of this particular expansion, 1 minus x whole to the power minus a. So x to the power r coefficient is c of n plus r minus 1 cr. Now you better tell me that whether you have seen this particular combination anywhere, c of n plus r minus 1 cr.
Yes, sir.
What is that? Where you have seen that? This particular combination. What is the speciality of this combination?
এইসব জিনিসটা আমি তো পাত্তা দিই না, তুমি কেন পাত্তা দিচ্ছ?
In which cases
Sir,
actually?
we have seen this in distributing object in boxes.
Okay, so okay, we have seen that, but a more appropriate answer I am expecting from you. This is a specific case. in some at some point of time we can definitely observe. That is actually a rule. That is actually a formula, and this formula is of combination and special type of combination, and I'm asking
Sir,
for that.
combination with repetition.
Absolutely, thank you very much. Exactly. So this is a formula which is combination with repetition. That is n plus r minus 1 CR. So in case of combination with repetition, you can remember that we can mention that one important properties you can observe, that is r value is greater than n. That means you have to select number of r out of n, but the important observation is your r which you will select, that is greater than your existing total number of objects, that is n. So that clearly indicates that your r must be or you have to select repetitively so that you can accommodate those r, because r is greater than n, otherwise it is not possible. You must repetitively consider certain object. So this is a formula which is combination with repetition corresponding formula. Now that formula is saying that is also a coefficient, that is also a binomial coefficient, and the binomial coefficient corresponding situation is, it is the coefficient of x to the power r. So x to the power r means we know that how many ways we can arrange r number of x object, r number of Cadbury, r number of chocolate. So if x is that category, so r number of combination, how many is there in case of 1 minus x whole to the power minus n. So that time the coefficient it is saying this. Now look carefully that if I replace the value of r by this n with some specific value, and what is the value? Say this one. How many ways we can arrange 7 balls out of red, blue and green balls? So 7 balls out of red, blue and green balls. So please specify me the what is 7 here and what are the indication of this red, blue and green. The way we are having these questions, so what exactly 7 is? What is 7 basically? It is asking, so with respect to permutation and combination, what is 7? And whether it's a permutation problem or combination problem, also you better specify that.
So 7 is the total number of basically total number of balls.
Okay, whether that is n or r.
So that is r.
That is r. So 7 means it's r. Fine. Before that you specify, is it a combination permutation problem?
Sir, it is a combination.
Absolutely, very good. Combination. And these r, that is 7, you have to select out of how many n? I'm asking for the value of n.
3.
Absolutely, very good. So n is 3, r is 7, and it's a combination problem, as
Yes,
he
sir.
mentioned. Thank you. So that is the observations right now we can obtain. And just because r value is 7 and n is 3 and r is greater than n, so one thing must be clear, that repetitively I have to select certain object, and that means it's a combination with repetition problem. Combination with repetition problem. And look it carefully that r plus b plus g equals to 7, that's the equation type of thing we have seen how to solve this kind of approach. How many solutions of this r plus b plus g equals to 7 are possible using the concept of combination with repetition? Already we have done using different manner. Now the fact is that the same problem we can represent using this format. What is the coefficient of x to the power 7 in that expansion, that is 1 minus x whole to the power minus 3. 1 minus x whole to the power minus 3. What is the expansions of x to the power 7? What is the coefficient of x to the power 7 in case of this expansion of 1 minus x whole to the power minus 3? So the same problem in different manner we can observe. This time with respect to that expansion of expressions, we are trying to say the same problem in a different manner. That is binomial coefficient of x to the power 7 in case of this expansion of this 1 minus x whole to the power cube. Now, one query I hope that must be coming in your mind, that how we are getting this 1 minus x whole to the power minus 3 situations with respect to this problem. How many ways we can arrange 7 balls out of red, blue and green balls? Because one thing we can observe that this is quite possible, this is quite sure, that is r plus b plus g equals to 7. How many ways we can arrange these equations, because total 7 balls we have to choose, and that way it is also indicating that some of the r balls by b balls by g balls repetitively we have to consider, so that the total becomes 7. These equations I don't have, I think that is quite clear to us. But what about this expansion corresponding? That means from where we are constructing this thing basically. Then the question of finding the coefficient of x to the power 7. To ensure that thing, that means how we can frame that one. So we are saying that is the approach of counting using polynomial we can apply. So that counting using polynomial approach, most probably you can remember. I just go back to the previous slide. This one. Wait a minute. Now that's the problem. I hope that this problem is clear to all of us. That means we used basically the approach of polynomial in this problem, and that time we observed that how we frame that polynomial, the individual row-wise polynomial, and then we identified that whether there is dependency or not, that is rule of product or rule of sum, which one? A rule of product, and then we multiplied all these individual terms and we framed the polynomial, and then from that polynomial we identified the coefficient, and that is the answer of a certain situation when k value is given depending on that. So that approach we have seen, most probably you can remember. So we use polynomial to solve this particular problem, and this is actually how many way we can plus b plus g equals to 7. Here we also can apply the same type of approach. The approach whichever we have the same type of approach. This time we will apply the 1, 2, 3. Also observe the first thing is frame the polynomial, then apply the rule, and then identify the coefficient. So in case of polynomial approach, you for the counting purpose, that is the quite common approach. That is, you have to frame the polynomial, then apply the rule. Rule means basically rule of product, not rule of sum, that kind of, and then identify the coefficient. So here the coefficient x to the power 7 already we have identified. That is, we need the coefficient of x to the power 7. So now we are going with this particular approach. That means how we can frame that polynomial so that the 1 minus x whole to the power minus 3 is coming. So the approach is that's the combination with repetition problem we have assumed, and this way we have framed that c of 9, 7 is coming, because your r is 7, n is 3, so n plus r minus 1, cr. I hope that is the 36 answer is clear. Now look carefully that in case of polynomial approach, the frame polynomial, so how we can frame the polynomial. Now this is the approach it is saying. Now look it carefully that what is going on here. So it is saying that how many balls I have to select. It is saying that maximum 7 balls. So that's why we are starting with this approach. First, think about that you haven't chosen any ball. So that's why x to the power 0 is the option. How many ways I can choose 0 balls? That is x to the power 0. How many ways I can choose 1 ball? That is x to the power 1. So these power thing, it is basically indicating the number of balls. So x square, 2 balls, x cube, 3 balls, and this way up to we are going. Once it is becoming x to the power 7, that indicates that how many ways 7 balls we can arrange. So the polynomial, total polynomial we are framing this way, and look it carefully that it is connected with plus. So x to the power 0 plus x to the power 1, x square, x cube, these expressions we are framing at first, and that is our polynomial expressions. And once we have framed this expression, then the next thing is saying that we have to solve this expression. And we are approaching this one plus x square x cube up to x to the power 7. So this way, this expression, if we try to solve, basically it's a summation of certain terms, 1 plus x square up to x to the power 7. So now the observation is that we are getting this 1 by 1 minus x whole to the power 7. So it's a sum of GP series, and that we are observing this way. And from there, we are observing that 1 minus x to the power minus 7 we are getting. And the sum of GP series we have applied, and then only we have got that 1 by 1 minus x to the power 7. And from there, we are identifying that n plus r minus 1 CR corresponding approach. And that's the same 36 we are getting. So the same problem but representation is different. Same problem but representation is different. This is about a definition of one board. Every time we are identifying x to the power 1, going up to the desired number of r. Framing one series, and then from that series we are observing that how we can identify the summation of those terms. So it can be AP series, it can be GP series. Right now it's a GP series we have identified, and then that way we have framed that that expressions, binomial expressions, and from there we are observing that yes, it's a formation of 1 minus x whole to the power minus n. And just because that is, then in case of rule we have seen that this type of expression generates a binomial coefficient, that is n plus r minus 1 CR. And accordingly, we are getting that the answer of this particular problem in a different representation, that is basically using polynomial we have solved. So the same problem in a different manner we have already seen, but this time this is with polynomial we have solved. Fine. Whether the approach is clear?
Sir, if in the exam it asks us to just solve the problem
Anyone,
without mentioning, so we can do anyone.
anyone, absolutely, anyone.
Okay.
But if it is mentioned using polynomial, then you have to use polynomial. It is based on this counting technique, so it will take 1 or 2 minutes. So try to solve that and ensure attendance. Right? And I must ask one thing. That is actually the way it has been decided. That is up to 5th of October. There should not be any class kind of thing, because no more topic as it has been decided that before midterm one, no more topics should be covered. Fine, but